Hello, 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 hello. How are you? I hope everything is fine with you after a difficult mathematics mock exam. Now it is time for the last but not the least important exam for today. And today we have a guest again who is Ege Aybars Bozkurt. Hello, Ege.
Hello guys, how are you?
I hope everything is well with you all. Again, I want to repeat it. Please subscribe to our channel, like our videos. Hello Gülşah Hocam, you are once again here. Now you are an advanced IB student after watching all those live videos. So today we will work on physics paper 1 because we found out that the most of the questions from our physics HL exam will be depending on paper 1 questions, multiple choice questions. So today again I try to find the best questions that will be helping you in tomorrow's exam depending on the questions that we took from our lecturer. So again, shall we begin?
Yes, let's begin.
Okay, just a second please. All right, we are ready. So the first question, by the way, if you have your answers also you may write them on chat if you think they are correct. First one says, a boy jumps from a wall 3 meters high. What is an estimate of the change in momentum of the boy when he lands without rebounding? So, for this question, the answer will be definitely C. But why? In this question, actually, our previous physics teacher used to say that it is all about knowing your limits. Again, do you remember that expression from our previous teacher? He used to say that know the time when the universe was created, for example,
Yes.
or some other things similar to this. So when you are talking about change in momentum, you may talk about mgh, and g plus h is already 30 here. So when we are talking about a boy, the best estimate here will be definitely C, assuming that he's about 20 kilograms. So our first answer will be C, definitely. Second question, do you want to go for it or?
Yeah, I can go for it.
Okay.
So it says a car moves north at a constant speed of 3 meter per second for 20 seconds, and then east at a constant speed of 4 meters per second for 20 seconds. What is the average speed of the car during this motion? So let's write this, and it says speed, not velocity. So we have to take the total distance traveled, not displacement. So let's sketch the information here. So first it goes north at 3. So it will go around, and then we multiply them, we will find 60. So it will go 60 meters. Then, and this is our beginning, we have to mark this. And then it goes east. And when it goes east, it will go this way. And it will go for 8 meters. So what is the average speed of the car during this motion? Actually, like we will find that this is 100 meters, and uh, and then we do the necessary calculations. And yes, Burak, what do you think about this?
This should be 3.5 meters per second. Because when we are thinking about it, so if we are going to east, actually the direction is right opposite, but doesn't really matter.
Yes.
So when we are,
it will go about like 140 meters in total, right?
yes.
So, yeah. So when we find the total distance traveled and then find these, actually we don't need this. I made a mistake here. So when we will find that we go for 40 seconds. So we have to do this calculation.
Yep, and it will be 3.5 definitely.
Yes.
And Dilara asked us a question: will HL and SL have a huge difference? Well, to be honest with you, when we were discussing with Ege, we realized that we didn't really do much of HL for physics courses because we realized that actually we have topic 11, electromagnetic induction, but it will not appear on the exam, and we didn't do quantum physics yet. It is HL topic, and we have fields and lines, right again? Fields HL actually,
Yes.
and we didn't have it on the exam either. I mean, in the class either. So maybe the difficulty levels will be different because there are some certain topics at which point HLs are asked to know more than SL students. And yes, Dilara, if it was saying velocity, we would divide it by 100 by 40 because now when it says velocity, it will be displacement over time. Wherever when it says speed, it will be total distance traveled over time. Next question. So the next question says, a student draws a graph to show the variation with time t of the acceleration a of an object. So what can the student deduce from the graph only, and what quantity from the graph is used to make this deduction? So we can find it says change in velocity or change in displacement. We will say we will be able to find the change in acceleration by using only this graph, because please remember that this is an acceleration graph. So we know that the area, let me draw it like this, the area under the acceleration versus time graph will give us the total change in velocity. We actually know it from mathematics as well, just like kinematics. And when we have a velocity versus time graph, let me write it like this. Oops. What is happening? No, not this one. Yeah. So when we have a velocity versus time graph, the area under the graph will give us, you can see it, right? Again, you can see the screen, right?
Yes.
Okay, no problem. So when we have a velocity versus time graph, we will be able to find the displacements by using the area under the graph. And by using the slope, I will write slope, we will be able to find the acceleration. And when we have an acceleration versus time graph, we will be able to find the change in velocity by using the area under the graph, and the slope will definitely give us change in acceleration. And I think it was called a jerk, but I'm not sure.
Yes,
change in acceleration, right?
It was called jerk.
It was called jerk. Like,
yeah, I think it means like inertia.
Yeah, definitely the inertia. How your body reacts to a change in acceleration, meaning a jerk, it would be. And yes, do we have anything else? Maybe we can talk about displacement versus time graph as well. Therefore, the area under the graph will not give us much, but the slope will definitely give us change in velocity, right?
Exactly.
Yes. And therefore, if it says such a question, acceleration versus time graph, so we will be able to find the change in velocity, and it will not be from the gradient of the graph. If we are talking about the gradient of the graph, it will be the jerk, rate of change of acceleration. Therefore, the answer has to be B. The next question. 4. Again, do you want to go for it, or do you want me to go for it?
You can go for it.
Okay, it says a mass is suspended from the ceiling of a train carriage by a string. So the string makes an angle theta with the vertical when the train is accelerating along a straight horizontal track. It says what is the acceleration of the train? So as far as I've understood, we can mention about the fact that the question is about, how can I say, inertia, right? It is definitely about inertia, because as it starts to move, we will have such a force. Therefore, we can talk about the existence of inertia, and it will be definitely g tan theta. It will be definitely c. But why? Because this tan theta will give us opposite over adjacent, right? Opposite over adjacent. So as we know the length of the string, and we know that it moved a distance, it definitely moved a distance. Therefore, we will be able to say that um, our string is moving in such a way because the acceleration of the the train is g tan theta. So maybe you can try to use fma as well. F is equal to m times a. So it will be definitely f over m, the acceleration. So we see the force in this way, force of inertia. Therefore, for this force, we can say mg tan theta, since it has a weight in this direction as well, right? But now, the resultant force would be definitely in this direction, and it is already shown from the direction of the string as well. But our m's will cancel each other out, and we will be left with the acceleration being equal to g tan theta. Is it okay? Should I skip the question?
Burak, I want to add something.
Yes.
Maybe there could be an easier way of solving this. Like, we know that, like, as you already said, tangent is opposite over adjacent.
Yeah.
But we know that, like, can you let me annotate?
Yes, of course.
Okay, so we have to get the part here. We have to get the component here. So we have to just, and we know that the vertical component is here. So we just multiply them to get the result here. Like opposite over adjacent times adjacent. And,
Yeah.
maybe like this. Yeah.
Definitely, yeah. Right, you're right. So the next question?
I think the next question is easy.
Yeah, it's pretty easy.
But we have to define, and we have to know the meaning of force here, force and kinetic energy.
Yeah.
Okay, Burak, can you let me repeat?
Sure.
Okay, so it says an object is initially at rest is accelerated by a constant force, and constant force is really important, which graphs show the variation with time t of the kinetic energy and the variation with time t of the speed of the object. So we know that it is accelerated by constant force, so let's write it. So we know that the mass doesn't change, the mass of the object. So we know that if it is constant, then acceleration must be constant. And when we take a look at the speed and speed time graph, then we should have a constant, we should have a straight line, not curved graph. Because the slope of this graph gives us the acceleration, change in speed. Actually, it's change in velocity, but it doesn't give us any information about direction, so let's assume it is velocity. So it is constant, it doesn't change curve. So it is definitely the one with straight line. So we eliminate D and B. And for the kinetic energy equation, we have this. And as you can see, it is exponential. And if it is exponential, then it has to go exponentially, like it has to form a curve like this. Let me write it here. It has to go like this because as v increases, as speed, as velocity increases, then the rate of the unit change will be higher. So it is A.
Definitely. Thank you very much again.
You're welcome.
So question number 6. Yes, so it says two stationary objects of mass 1 and 2 kilograms are connected by a thread and suspended from a spring. It says the thread is cut. Immediately after the cut, what are the magnitudes of the acceleration of the objects in terms of the acceleration due to gravity g? So again, actually this was a question that came up in the exam. Do you remember that?
Yes, and I did not do it correctly.
Yes, me neither. So, first of all, let me give you the answer. The answer will be D. Why? Let's look at here. So, we know that now this object is at rest, right? And it is being pulled down normally with a 2 kilograms of thread. So now let's imagine that we are doing such a thing. F is equal to mass times acceleration. So our acceleration will be equal to force over m, let's say. And when the thread is cut, we know that as the 2 kilograms mass is going downwards, the spring will pull our 1 kilogram mass. Why? Because we know that as the 2 kilograms is going down, since it is asking immediately after the cut. So 2 kilograms means 2g. Therefore, at this instance, the Newton's third law, action and reaction, as the 2g is going down, it will go up with 2g because mass of 2 kilograms is leaving, and similarly the 2 kilograms will have an acceleration of only 1g because it is being pulled normally up with a 1 kilogram. So 2g minus 1g, it will have a 1g acceleration, right?
Yes.
Yep. So question number 7.
Let's take a look at it. Okay. So it says an object of mass 2 kg is thrown vertically downwards with an initial kinetic energy of 100 joule. What is the distance fallen by the object at the instant when its kinetic energy has doubled? So let's write this equation. 1 over 2 times v squared. And we have to find the velocity it is thrown with. So we can eliminate these, and we find that velocity is 10 meters per second. It is thrown with this velocity, really. And what is the distance fallen by the object at the instant when its kinetic energy has doubled? So we have to know about and here we have to know about the gravity. And Burak, do you have any idea how to do this?
So as it says, a 2 kilogram is thrown vertically downwards with an initial kinetic energy of 100. It says the distance when the kinetic energy has doubled. So we can write the equation like this, I hope. mgh will be equal to 1 over 2 mv square, and since they will cancel each other out, we know that it has an initial kinetic energy of 100, and this part means that the height was 5, right?
Yes.
1 second please. Actually, the answer has to be B as well, because its kinetic energy will be doubled, right? Oh, initial kinetic energy is 100. Okay, sorry. So we know that V is equal to 10 meters per second at the beginning, right? It's equal to 10 meters per second. So as it will go down, its kinetic energy will be doubled. Therefore, we are looking for the point where it is going to be 200. So in order to make it 200, we have to increase it by 100. And this 100 will come from its potential energy. Therefore, we know that since gravitational potential energy is equal to mgh, we know that it is 2 kilograms and g will be 10. Therefore, to make it 100 plus 100 joule, we have to have a height of 5 meters. So the answer will be, so we know that at the beginning the kinetic energy was 100 joules. Now we want to make it 200 joules, and this 200 will be obtained directly from the conversion of gravitational potential energy into kinetic energy as it falls down. So we are just writing mgh, we know m and g, and we need h, and the result should be equal to 100. That's why the height will be 5 meters. B. So, again, what do you think about going with the selected questions?
Yes, I think they will be better.
So those are the questions from the topics that we wanted to focus on the most, because we believed they will be asked very frequently in the exam. So the first question says, the graph is a speed versus time graph. So it says the distance traveled by object during the first 4 seconds. So we will directly just find the area under the graph, and it will be equal to, this area will be equal to 20 times 4 over 2, since it's a triangle, and it will be equal to 40 meters. B. This was an easy question. Now this is the second question. Again, let me make you annotate this. Yeah.
Okay. It says a ball is initially at rest, is dropped in the air from a great height. Air resistance is not negligible. It is very important. Which of the following graphs best shows the variation with time t of the acceleration a of the ball? So we know that and in this part we have to know about the concept of terminal velocity. So it means that it is going to have a constant velocity after some time passes. So when we take a look at here, like it does not have a constant velocity. It always increases, and then
So the deceleration will be decreasing,
yes,
and
so
then it will remain constant after a while.
Yes, and it cannot happen. So we look at here, and it cannot happen as well, because we have acceleration, but in constant velocity we don't have it. So we eliminate this part too. Here, when we think about it, it's not possible, because it cannot have a straight line. I mean, the reason is that like when we consider the physical conditions, then it's not possible.
And it has an increasing acceleration and also not a deceleration, whereas
Yes.
our object is going downwards.
Yes, exactly. And the most sensible part is C, because after a while it will reach terminal velocity and it will have zero acceleration. So the correct answer is C.
Yes. So the next question. It is about, again, mechanics, and it says two cars of different mass, small m and capital M, are connected by a spring. So it says they are pushed together such that the string is compressed. Spring, sorry. So it says when the cards are released, the mass with the small mass is moving right with velocity v. What will be the change in momentum of mass m? So again, we will be talking about Newton's third law of motion. Newton's third law of motion will tell us that if this is m and this is m, when this is moving in this direction, you may be asked about this question with a tennis racket and a tennis ball. So when it goes in this direction, since they are connected to each other with a spring in compressed version, it will be now expanded. So this capital M will be also pushed in this direction with a momentum of mass times v. But now let's see. It will not have any effect about its greater mass, because now it is being actually pushed by this small mass, small m. Therefore, change in momentum will be minus mv, because it is, look at it, towards left, right? Towards left. That's why we will say negative mv with small m. Nice. So another question that showed off previously in our questions. Again, do you want to do it?
Yes, it is very. It's not tricky, but it requires great like consideration. You have to be very careful. Okay, can you look on?
Sorry. Yep.
So it says the diagram shows a girl attempting but failing to lift a heavy suitcase of weight WB. So let's write it. So we have to illustrate. When you are writing, when you want to solve a question, just draw them. It will make your life easier. The magnitude of the vertical upward pull of the girl on the suitcase is P. So the girl is P. And the magnitude of the vertical reaction of the floor on the suitcase is R. Okay. So it says, guys, we need to be really careful in this part, because it says it shows a girl attempting but failing to lift. The important part here is about the equilibrium part. So when we wait a second, okay, I forgot to put it. The most important part here is to have an equilibrium, because when we add them up, and when we add these parts, the girl is not exerting enough force, and the suitcase is not moving. So we have to have an equilibrium part. When we take a look at these, and because they are in the same direction, let's put them down. Because we have no movement, then it should be equal to W weight. They should be equal to the weight. The correct part is weight. And I think we have to be really careful in this question.
Yeah. The important point is about it's not moving. And by the way, if it was moving with constant velocity, it would be still A.
Exactly.
I mean, there will be an equilibrium, because net force has to be zero if it is either in stationary motion or in constant velocity action, according to Newton's first law. So the next question is about the mass of a planet m and its radius is r. In order for a body of mass m to escape the gravitational attraction of the planet, its kinetic energy at the surfaces of the planet must be at least. So at this point, we will be talking about escape velocity. V escape, I will write. Okay. Escape velocity will be equal to 2gm over r. This is given.
By the way, this is given in the
yes.
Yes. Sorry.
Data booklets. So, therefore, we know that since it asks for the kinetic energy, isn't it 1 over, let me write kinetic energy, 1 over 2 mv square. So just substitute this v escape into this v. Therefore 1 over 2 m, since it was square root, now I can write 2gm over r. Those 2's will cancel each other out, and then we will be left with gmm over r. By the way, this is not 2. Why did I write 2? Yes, gmm over r, which means that our answer will be equal to A. Did you understand it? Please remember that in gravity questions or circular motion questions, you are asked frequently about substituting from data booklets. Because, for example, Kepler's constant, again, I think you should remember it from last year's courses. We had to calculate the value of K for many times. And this is like 7 marks question because it goes like 1A, 1B, 1C. That's why we have such a movement. Next question. Again, you want to do it? Let me make you annotate this.
It is very simple chemistry question.
Yeah, it is a simple chemistry question.
Okay, let's solve this. Okay, it says carbon has a relative carbon.
Carbon. Hi.
Carbon has a relative atomic mass of 12, and oxygen has a relative atomic mass of 60. A sample of 6 carbon has twice as many atoms as. So it talks about molarity. So we know that it is 12. So we have to divide the mass of carbon by its molar mass, and we have 0.5 mole. So it has to, and this one has to have the double of the atoms of oxygen. So we have to divide this part by 2 so that we have the mole number for oxygen. So we have to multiply this mole number with oxygen's relative atomic mass. So when we do that, we find it. There you go.
So
if you are taking chemistry, then you will be very comfortable with it.
Definitely. So again, do you want to also go for the next question? Tanya, about Tanya. Hello, Mrs. Smiley. Hello, Mrs. Smiley. I hope everything is fine with you. Let me make you annotate this.
I hope she is watching this.
Yeah, I hope.
Okay, Tanya heats 100 grams of a liquid with an electric heater which has a constant power of 60 watts. After 100 seconds, the rise in the temperature is 40 and the specific capacity is asked. So let's write this. Let's write the equation for specific heat capacity. So it's not the equation, but it involves specific heat capacity. So we have to make the necessary arrangements. Yes. So we have to have this one. So we know that in order to have the energy, and this is the energy by the way, in joule, we have to have in joule, and you can check this here if you want. The necessary units, and it's very important to take a look at them. And you can even derive this if you don't know this equation, and although it's given in the data book, you can still find this, derive this. Okay, so it is asked 100 seconds. So we have to multiply 60 with 100 so that we find it in joule. That's fine. Let's write it here. And then it is asked. So we have to find the mass. So it is 0.1 kg times the rise in temperature is what? Which one is it? That's it.
Yep, great. So the next one. Okay, so this is about the behavior of 1 second. Behavior of real gases is different from that predicted for ideal gases. Which of the following statements about real gases is not correct? Okay, is not correct. So at this point, we will be checking the answers. Gas molecules have potential energy. Let's remember that. According to ideal gases are assumed to not have a potential energy. So A should be correct because we are now looking for real gases. Real gases have potential energy. Yes, this is correct. B. Forces between gas molecules are always negligible. Now, this is wrong. This information belongs to ideal gases. Because we assume that the gas molecules are small dots with negligible volumes and negligible attractions between them. So let's look at C. Gas molecules have volume, yes, but ideal gases have an assumption of not having any volume. Real gases can liquefy, yes, because they can be compressed, whereas in ideal gases we said that they cannot be liquefied because we assume there is no attraction between them, between the molecules. So the answer is B. This one, again, do you want to go for it?
Yes, of course.
Okay.
Okay.
Sorry.
It requires use of this equation. I'm checking the data booklet. So yes, let me write it down. This is resistivity R A. Actually, A, let me write it by this way. Diameter. Oh my god. Yes. It should be radius because that's why and it is length. Alright. A cylindrical conductor of length L, diameter D, and resistivity P has resistance R. A different cylindrical conductor of resistivity 2P. Okay, so we have to arrange this. Okay, so it will be resistivity 2P. Okay. 2L. Okay, and 2D. If it is 2D, then we have to multiply this by 4. So, because there's a square, but before it was d over 2. So, we have to, when we do the calculations, these will cancel each other, and then they will still have r. That's it.
Definitely. Let me stop annotation and sync physics because I found a new question. I hope it will load soon. So by the way, is there anyone from our viewers want to revise a topic or a solve question about it? Because if you have it, we can help you about them. Okay, the next question is here by the way, but I am looking for chat, so if you have any questions, we can take it. It says the diagram below shows a particle with positive charge Q accelerating between two conducting plates at potentials V1 and V2. So it says what is the kinetic energy gained by the charge? So we have to remember that kinetic energy in such motion will be given by change in voltage times charge Q. So when it comes to kinetic energy, we will be change in voltage. We will say that it will be the initial voltage minus final voltage. Therefore, it will be C, V1 minus V2 times Q to find how much it is gained. So we will say definitely C. I see Kirchhoff again. We have a request about Kirchhoff problems.
Okay. Actually,
Okay.
the ones that is asked in the IB are very easy.
Yeah, they are not really that difficult.
Yeah. Don't worry about that, but we can revise them. Right? Of course, why not?
So, again, what do you think about this? I will just open a question from our previous paper, and it will be one like, let's say, not this one. Oh, maybe you can look at this one again. Meanwhile, I'm bringing another question. Maybe you can talk about why this should be D.
D.
Yeah, it is D, and I will find a Kirchhoff's problem for you.
Okay. Okay, guys. Let's talk about them. Although Mr. Rafik did not say that he's going to ask a topic from topic 9, it is HR topic. Let's revise. Okay. So it says monochromatic light is incident on a double slit. Be careful, it is double slit. Both slits have a finite width, and the light then forms an interference pattern on a screen some distance away. Each graph shows the variation of intensity with distance from the center of pattern. So let's take a look at this and let's pull up the equation about this question. I'm checking the equation. Wait a second, please. Yes, it is in 4. 4 to check. Yes. The light then forms an interference pattern in the screen on this specific. So it has to be B because let me out of it. Let's say we have double slits and I drew it so long. There will be light here and light here. There will be diffraction. There will be diffraction. There will be destruction in superposition of waves. Destructive interference. So it has to be B because we can see that on the screen here there will be some parts which is more brighter than others. And this is actually what it explains here. This is fringe. Fringe is the distance between the light, the dark or light light spots. Let's say that there is not destructive but constructive interference. So this is going to be the bright spot, and they will have they will be equally spaced. And this is what it explains in fringe. And it's not HR topic, guys. I made a mistake. It is SM topic, and also it is for HRs as well. So it is going to be B. That's it.
It is for D again, by the way.
It is D?
Yes. Because it would be like B, it would look something similar to B if it was a single slit diffraction. When we have double slits, since there will be superpositions within the same peak as well, and superpositions will make it look like D. And this is because there will be some gaps between the fringes when it is like Young's problem. It is a double slit.
Yes.
So, shall we go with Kirchhoff now?
Yeah.
So, for Kirchhoff, let's say Kirchhoff here, and let me make it like a grid line. So Kirchhoff's first law states that the total amount of current in should be equal to total current out in junctions, right? In junctions. I will mention what they mean in detail in a second. And second law states that total amount of voltage in is equal to total amount of voltage out in the circuit. So let me tell you, if we have a junction like this, imagine this, and I will say I have I1, then let's say I will change just this direction to have a variety, and this one as well. So I have I1 in this direction, I2 in this direction, and let's say I3 in this direction. Therefore, I will look at it. Let's look at I1. I will circle the ones that are entering the junction, the currents that are entering the junction. So I1 is definitely entering the junction. And let's mark the ones that are emerging the junction with the red color, I2 and I3. So since we said that I in, current in, and current out has to be equal, can't we say that I1 has to be equal to I2 plus I3, right? So if we have a Kirchhoff problem like this, where is my, it's here, okay. Let's say we have a Kirchhoff problem like this. We will go step by step. Let's say this is a circuit, and I will say that let me do it like this. I have a battery here, and I have a resistance here. It is 200 ohms, and let's make it 9 volts. Then for the middle, let's have another resistance, and it will be 100 ohm in the example. And let's make this one 1.5 volts. So when we have a Kirchhoff problem just like this, let's first identify the junction points, okay? Let me call this one J1 and this one will be J2. This is the point where the two circuits are coming together. Yes, in some of the questions the cells will be connected in different ways, and it is going to be pretty easy. Let me just tell you how it will be like. I will assign some directions for my currents. It is completely random, by the way, okay? I will say that, first of all, since I have one circuit here, I will say this will be I1, okay? And let's say the current here is I2, and I will say this is I3. I completely made up the ways of the current, directions of the current, because in the following parts of the question, if I find a negative result, as you may remember, I will just reverse the direction. And if it is still positive, it will remain the same. Therefore, let's look at the junction points, okay? Let's talk about J1 by using Kirchhoff's first rule. We said the entrance versus emergence will be equal to each other, and in this case I1 is equal to I2 plus I3. Why? I1 is, as you can see, entering the junction over here like this, whereas I2 and I3 are emerging from the junction. So for junction 2, let me say J2, it will be definitely I1 is again equal to I2 plus I3, and this is the same equation. Why? I1 is emerging, whereas I2 and I3 are entering the junction. We are done with the first one part. So let's assign some clockwise or anti-clockwise directions for our loops. Okay, let's just assign them. I will say, let's say clockwise for both of them. This will be my loop A, and this will be my loop B. Okay, so since we are done with this part, I will just say let's divide it. Let's talk a little bit about loop A. So when we have a loop, you may think about it just as if it was a, how can I say, ladder, okay? Starting from the battery, the cell, it is at the highest point. So if you are following the direction of your loop, this means that your energy level is decreasing, because as you follow the current, let's say that your ladder is in the shape of a spiral and your battery is an elevator. Okay, let's say here is your battery. Okay, here is your battery, this is an elevator, and let's call this one being the positive side. Okay, the positive pole. So as you follow the current, your ladder goes down to the negative pole, and then your battery gives energy to the particles and then elevates it back to the positive charge, then goes like this as you follow the current, then goes up, goes like this and goes up. So if you are following the direction of your loop, this will be negative. Okay, this has to be negative. Now let's see. Let's start from J1. Okay, let's start from J1, point J1, first junction. As you can see, I will follow my loop A direction, and as I am going through it, I see that, oh, in the middle wire I have I3, and my loop A's direction is as same as I3, so I am following the direction of my current. Therefore I am going down the current. Therefore I will directly how can I say, write that I, or let's choose blue color, minus I3 times 100 ohms. Why did I multiply them? Because voltage is equal to current times resistance. Current times resistance. Therefore, it will be definitely minus I3 times 100. Then I am following the same direction, and I am now at the left bound, and I see my 1.5 volt battery. So let's say if you are following your loop and you see the negative sign first, okay, you came across the negative sign first and then the positive pole of your battery, This means that you are now in the elevator, okay? You came down the current, now this is the negative pole, just like in this case, in this question. So it will be elevated up. The energy, you are not losing energy, you are gaining energy. Therefore, this will be definitely 1.5 volts. Did you understand this part? Like the elevator, you are gaining energy. If you are going from the negative within the battery, but this is important, within the battery, if you are going from the negative pole to positive pole, it should be positive. But if you were in the reverse direction, if you were going from the positive pole, you came up, 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 you came across the positive pole first and then the negative pole, this would be negative, unlike this case. So let's see. And then what would it be equal to? I started from J1. Oops, I came across resistance. Okay, the wire. Oops, the battery. I said plus 1.5 volt already, and only wire, and again J1. Therefore, this would be equal to 0. Now, let's look at loop B. Now, in loop B, let's again start from J1, okay? Let's start from J1 once again. So, I am following the direction of about loop B, and I see that, I realize that I2 is in the same direction. So, it will be minus, because I am going once again down the stairs, down the ladder, okay, down the stairs. So I will directly start with negative 9 volts. And now let's say plus for now. And I am going, and then 200 ohms resistance. Now, since I know that I am going down the stairs, and I am following the direction of my current, so I am losing energy, losing voltage, decreasing voltage, it would be voltage is equal to current times resistance. Therefore, I will say minus I2 times 200. Why minus? Because I am following the current. Then I am leading the way, and then I am now at J2, the second junction. Now let's go up. As I go up, now I am in the middle wire. I see that my loop B is in the opposite direction as I3. What does it mean? Now this means that you are now going up the stairs. Okay, up the stairs, because you are now opposing the direction of your current. Your loop's direction is opposing the direction of your current, so it has to gain energy. Now this time voltage is equal to I times R, but this time's positive because we are going upstairs. So I3 times 100. And now let me go up, and I am at again junction 1 again, the initial point that I started. So sorry, it will be again 0.0. Therefore, what you can do here is that since you have the value of I2, now we have 4 equations, okay? 4 equations and 3 unknowns. What you will do is you will substitute each one into each other. Okay, for example, you have the definition of I1 here. You can substitute it into your equations. If you have them, you can just allocate I3 or I2 from the equations over here, just like in here. So I3 will be equal to 1.5 volts over 100 ohm. So you can do all those things. And let me tell you what will happen at the end. If the currents that you assigned give you negative results, this means that the first the initial direction that you assigned has to be reversed. For example, let's say I'm assuming I didn't calculate it, but if I1 is equal to, let's say, negative 1 ampere, this means that it shouldn't go in this direction. It should go in this direction. And if it is positive, keep it in the same way. So, okay, oh, sorry. I didn't see the questions, I'm just looking at it. I3, yes, yes. The directions are assigned completely randomly. Completely randomly, okay? You just say, okay, let I1 go in this direction, let I2 go in this direction, and let I3 go in this direction. Okay? And usually they are given, by the way. Usually they are given. They are given. And one more thing. Loop A and loop B. Actually, you assign the directions of loop A and loop B randomly as well. For example, if you said loop A is clockwise, if it is negative, again it will be in anti-clockwise direction. Again, did I miss any points while explaining it, or was it a good explanation?
I think it was a good explanation.
Yeah, right.
We just have to know how to put the directions in
Yes.
and how to create the equation, and the rest is just mathematics.
Exactly. 4 equations, 3 unknowns. You are welcome, Dilara. So, again, shall we call this a day after giving some tips for our followers?
Yes.
So,
why not?
What I would suggest you do, we were talking with Ege as well. We suggest you to go to ExamMate rather than finding a past paper, because our teacher said that we will be missing a lot of topics in the exam actually. For example, like fields HL. We didn't learn fields HL yet, or we didn't learn quantum physics yet. We learned about electromagnetic induction, but we learned that it will not appear on the exam. And we are learning right now topic 9, particle physics, but now we know that it is also not on the exam. So this means that the topics will come presumably from the previous chapters. Therefore, please try to focus on paper 1 questions. Paper 1 is in the majority, so you may want to solve paper 1 questions mostly. And you may try some paper 2 questions on your own. For example, Kirchhoff. I tried to revise Kirchhoff. Now I think it's the perfect time to go with the books, either the revision book, the workbook, or the textbook, to find some Kirchhoff problems. If it would be better if it is a worked example, just try to understand it. And then you may solve some circular motion questions, and so on and so on. And try to solve as much paper 1 question as you can, and try to solve them from topical past paper questions. Selected topics that you feel the most concerned about, because although we solved some of the questions, there are some tricky questions. All the options are given. It is just as if it was an open-ended question. Am I right again?
Yes, I think it will be all past paper questions.
Yep.
So paper 1 questions.
So about
Like
paper 2, we shouldn't concern much, I guess, right? Because we don't have that much time.
Yeah, exactly.
On the exam, it is only 1 hour, and we learned that the majority will be paper 1 questions. And we also heard something. This is like a conspiracy theory, let's say. 30 paper 1 and 10 paper 2 questions, like 10 marks paper 2 questions. This is a conspiracy theory, I am saying. Yes, definitely. So we wish you the best. If you have any questions regarding this physics exam, please contact us on Felsefesinde, or if you have our numbers, etc., Instagrams, such things. You can contact us from those platforms as well. Just send us your questions, we will try to help you. So this was the end of the live video. Thank you very much again for being in this video once again.
Thank you, Burak, for hosting me.
You are welcome. It was a great pleasure for me too. So we wish you the best. Have a nice day. Good luck in your exams and make sure that your calculators are fully charged and you are ready for the exam. You are welcome. My pleasure. As I said, if you have any past paper questions that you are feeling confused about, please send them to us. We will try to help you out with that. Or any revision topics, I can try to share the notes if I have them. So, see you everybody. Bye bye. You are welcome. You are welcome.